Looking at space has always guided us in learning more about ourselves and continues to be a source of inspiration in science and scientific advancements. Space is a projection of hope, and because it is so mysterious, it has a spiritual dimension. But space is also an area of global cooperation, where national boundaries are overcome effectively and humanity comes together to dream and build the future.
However, a lot of work has to be done to colonize space. Since 1972, no human has set foot on the moon's surface. The hurdles are not just of technical nature, but also of political and economic nature. Even the complexity of a rocket with thousands or even millions of pieces to assemble and complex supply chains remain a challenge to this day. Yet in 10 years from now, humanity might have established a permanent presence on the moon or even Mars. At least that's NASA's goal. Will we achieve that or even more? Only time will tell.
Let's dive into it.
Today's topic is very out there, but recently news about it has skyrocketed. Yesterday, for instance, was the first birthday of the United States Space Force.
We are moving forward in space exploration in recent years. Competition has increased and the landscape of the industry has been transformed thanks to active players like SpaceX.
So if we take a look at the timeline for the next few years, we could see that Elon Musk plans to have unmanned missions to Mars by 2022 or 2023. NASA plans to have humans on the moon with their Artemis project, which is a collaboration with many partners. 2026, we could expect humans on Mars, according to Elon Musk. And 2028, NASA would like to have a presence on the moon. So
Exactly. So what we cover today is we will give you a brief introduction into space itself, and we will discover how space could help us. Then we will look into space travel and logistics, talking about rockets, talking about payloads, bringing payloads to space. And then we talk about space habitation and resource exploitation. And finally, as always since the last episode, we will dive into a utopian day that will be interstellar. So yeah, let's start.
So there are some things that we have to understand about space because there are some inherent challenges that are involved in mastering space colonization or making it even possible. One is the vastness. So space is so infinitely large. You have planets, and in our solar system, we have 8 planets together with the sun and the many asteroids. They form our solar system. Then we have trillions of other systems that form up our galaxy, the Milky Way, and in the observable universe, which is the universe that we can see, just observe, there are about 2 trillion galaxies. And then you have clusters of galaxy groups. And this basically means that when we're talking about traveling between solar systems or between other parts of the galaxy or even between galaxies, we're talking hundreds of thousands, even millions of light years, which means that the time it takes, if we were to travel at the speed of light, would be centuries and millennia.
Yeah,
Go ahead.
We know all of this only not because we've been there, because most of it's just based on telescopes. The farthest distance that we've ever traveled or that we've ever been is where Voyager 1 and 2 has taken us, with Voyager 1 currently being at 22.8 billion kilometers of Earth. And this is after 40 years of operation. The speed that it has reached is 17 kilometers per second. If you compare this to what we consider our current limitation, which is the speed of light in vacuum, that is not much, because that would be 300,000 kilometers per second. And this is also referenced versus Earth. So it's huge.
Yeah, so it's fair to say that we still have a lot of technological innovations to even break the speed of light or go beyond it to make space colonization a reality. And maybe more talking now directly about space, just for a short introduction, Many galaxies, ours included, are thought to have a supermassive black holes. So these aren't just black holes, but they're supermassive, they're huge. And the way black holes form is you have a lot of mass condensed into such a small, tiny space that nothing, not even light, can escape it. Each black hole has its own event horizon, where once you cross this event horizon, you cannot escape the black hole, even lights. Then we have dark matter. We know today that about 97 to 98% of all matter in the universe is dark matter, and we just do not know what it's made of or how it behaves.
Yeah, it also doesn't reflect light, so we cannot visibly observe it. So if we study the origins of the universe, it all starts essentially at the Big Bang, where elementary particles are tied together in a small space, and they then explode and expand into everything that we know today. The universe is still expanding. And the alternative idea is a big bounce, where you have a process between expansion and contraction, where the expanded universe at some point collapses because the gravitational forces take over. So the galaxies are not holding together anymore, which we call the big bounce idea. But in any case, we can actually observe the universe. We can travel back in time because the speed of light is limited, and because time is part of space in what Einstein said in relativity. This is a huge field of research, and one that has not been fully developed yet.
Yeah, so relativity basically means, right, picking up on what you said, that because everything is constant in movement, we can really only measure things relative to our speed, relative to our location. So this makes it really hard to have absolute observations. Further, the understanding that we have today in the scientific community is not that gravitation is not really, doesn't exist, but that we have a four-dimensional space-time surface, the curvature of which we call gravity. So gravity is merely a curvature in space and time. And because space and time are correlated, this means that if we travel in space, we are also traveling in time. Makes sense, right? Time always moves forward, and we are moving through time. And another important fact is entanglement. And would you want to explain what entanglement is?
So some suggest that explaining dark matter is tied to explaining what we don't know yet, which is quantum mechanics. And both entanglement and superposition, which are the two core principles of quantum mechanics, are crucial for understanding much of our universe, is what is suggested. So entanglement essentially is enabling anything that is part of it to travel faster than the speed of light. Because entanglement means that two particles with an infinite distance between them behave the same way. And there must be some sort of connection in between them, at least to our current understanding, which is not that far, so that they can move into the same direction at the same time. This could also explain something like coincidence. It could explain randomness. So very interesting part. And we talk about something that is faster than the speed of light, and this might also become relevant when we talk about space exploration, where we need to cover a vast distance and thus need to be very fast to essentially do anything within a certain amount of time. The other part is superposition, and that's something that really messes with our reality, because things are not what they seem. They depend on who looks at them and when we observe them. And this even means that when we observe something in the future, its past is changing. So this could be connected to understanding spirituality and consciousness and how we look at reality. So very, very interesting to look at this.
Yeah, absolutely. Another aspect that is maybe important is a question that I'm sure everybody has asked themselves: do aliens exist? So we know that there have been many UFO sightings, the hype around Area 51, maybe the possibility that they're harboring aliens. patterns in cornfields. But as of now, we don't have any concrete proof of life on other planets, because for life to evolve and sustain itself on a planet, there are many conditions, right? You need to have the planets in question has to be in what is known as the habitable zone of the star that it's orbiting, meaning that there's a specific range in which the temperature isn't too high or too low. Then there are other things such as an abundance of water, carbon, and other factors that are important, such as an ozone layer or any type of atmosphere that blocks solar radiation. But given that the universe is vast, right, with millions or even billions of galaxies, each with trillions of stars, with multiple planets, the probability that there is a life form out there is quite high. But that doesn't mean that we could discover them. Maybe they are just too far away. Maybe they are just starting out as microbes. Maybe they already had a great galactic civilization that was wiped out, and all we have left are remnants. So these are interesting questions that will come more into question once we have really mastered space colonization.
Absolutely. And another question is the question about why we should explore space at first. Why should this even happen? And there are several reasons when we look at it. And a predominant one is that it gives us additional habitat and additional resources apart from the ones that we have, and this in huge numbers. So we will talk about asteroid mining as well. And we will talk about what could be the most likely scenario of us habiting or of us inhabiting another planet, and which one it could be. Now, it enables us to explore space itself more, which could give us also a safety advancement, because we don't know too much about medium-sized asteroids, if and when they would hit Earth. We know that the likelihood is pretty low, but there is at any point in time some scenarios like this could happen, because currently, and this might scare you, but currently we cannot track any and all asteroids that could create significant damage on Earth. Another one is the idea of international collaboration, which we see essentially since the 60s, when the Outer Space Treaty was signed, which manages how different nations can interact in space and what they do with the resources there, and that they should preserve the integrity of space and work together with each other. Now, another thing we've already discussed, which is relativity in quantum mechanics, which could be at the key to solving a lot of problems on Earth itself. It could help us to explain spirituality. It could help us target any mental diseases that we face, or any other problems at Earth. So there is huge potential impact of us understanding space further. Also when it comes to quantum computing and artificial intelligence. But let's go a bit more concretely into what we mean by the space industry, essentially.
Exactly. So the space industry has many components. I think the most widely known is the satellite industry, right? Satellites today are predominantly used for communication, navigation, and research. So in the communication side, you have things like the internet bouncing signals, the fact that you're able to listen to radio on the other side of the planet. Navigation, because the global positioning system, or GPS, is based on the triangulation of 3 satellites and their distance to you. And this algorithm then determines your exact location on the planets. And for research, for instance, to discover laws of physics, to prove theories. In fact, there are 2 satellites known as Tom and Jerry, after the famous cartoon. These are essentially 2 satellites that chase each other, and they aim to prove what happens at higher speeds and what happens at different speeds relative to one another. So as of 2015, the satellite industry was $200 billion. Satellite transportation in 2020 now is only about $5 billion, but is predicted to grow to $30 billion by 2030, because we will definitely see kind of these mega constellations, bigger projects as space transportation becomes more cheaper and more affordable. More and more companies can join the game, maybe even build bigger satellite systems in the orbit. And I even read that in the next 2 years, they expect about 5,000 satellites to be launched. That's a lot of launches. And 75% of all the companies launching these satellites have already flown something to space. I mean, the most popular one that people know is probably Starlink, where they try to create a global internet by sending 60 satellites every launch. So satellites are something that kind of everybody has to or wants to own these days. But yeah, I talked on satellites.
So space logistics is really the catalyzer today. The reason that we talk about this, the reason that we have hope for significant advancements in terms of the space industry or colonizing space in the future, or let's say in the next 10 to 20 years, is space logistics, because it enables companies like SpaceX to have a viable business model and to continue to do research. And how do satellites actually reach in space? How do we bring anything into space? Currently, it's predominantly with rockets. What are the main factors that rockets that we need to look at when we talk about rockets?
So the factors that we know that are relevant today are, one, the cost, right? How much does it cost, not only for the rocket but also for the load? And attached to that, what is the capacity? What is the load capacity? How much can be transported? This strongly impacts the size of satellites, and thus an improvement here would mean, more possibilities. Then we have fuel, right? How efficient is it to bring it? How much fuel is needed? Navigation. We have speed, reusability, which is a big point where SpaceX has done a massive breakthrough with their landing booster rockets. Then we have the materials involved, and finally the weight.
Yeah, we look into all these factors. The first one is launching and landing these rockets and their stages. So currently what has been done is usually we have a 2 or multiple stage to orbit, which means when a rocket leaves the Earth, it has a stage attached to it, which is the initial power, is initially powering the whole thing. And then at some point before vacuum is reached, and before the whole package reaches the low Earth orbit, the rocket detaches and then powers itself when further moving into the LEO, into the low Earth orbit. The rocket, as well as the initial carrier, can or should be reused because they have long production. They have very expensive, let's say, production and development processes. So every time you can reuse these, that's a huge efficiency enhancement. So any sort of advancement when it comes to reusing both of these components is very significant for us when it comes to space logistics. What SpaceX is doing, for instance, is in order to catch the carrier when it lands back on Earth, is they have a drone ship in the ocean which catches the carrier when it lands there. So yeah, another important part is weight. Weight is really relevant for fuel efficiency, obviously, but also when it comes to acceleration and when it comes to increased payload. All of this is very expensive, and setting up a rocket to fly, as we've seen in the past, is something that takes a lot of time. And SpaceX currently is shortening and also other companies, especially startup companies in the space industry, are shortening the time for setting up and starting a rocket. So yeah.
Exactly. So yeah, the time frame and the cost, they've all gone down drastically. And yeah, I think we can, take a look at I was astonished that there are many, many companies that are involved in the space industry. We'll get to the more obvious institutions later. But one of the bigger startups that we know is Virgin Orbit, launched by Richard Branson, which is part of the Virgin company. They have not launched yet, and they tried this revolutionary idea, or they're considering this launch location to change, and this could be quite a game changer. Recently, they had their plane, the Strato launch, which the idea behind is that you can launch a rocket from midair, meaning that rockets wouldn't have to generate all that thrust, but that you could, like a plane, just take off midair and just glide higher. So they have not launched yet, but it's a very promising idea.
One of the bigger funding rounds this year was Relativity Space. They've raised $500 million in Series D in November. And what they are planning to do is launching the first fully 3D printed rocket next year. They have the largest 3D metal printers in existence. So they are really focused on high tech and on reducing the cost of building a rocket, and also increasing the standardization and industrialization of the process. They are planning to use less than 1,000 parts for a rocket, which historically we've been at hundreds of thousands of different parts, or even millions for a rocket. So 3D printing enables them for a much faster process, including product testing and improvement in their cycles. And they are actually down to 60 days when it comes to planning and prototyping an initial rocket.
Yeah, then we have this startup Astra. They reached space very recently on the 15th of December. And this is a startup that, just aims to provide cheap transportation, payload transportation to space. There's no, it's a logistics company, a very advanced one. But their focus is mainly on cost and process optimization. So their idea is to only have 5 people set up and launch a rocket, which is very ambitious.
Yeah, interesting story there. When they tried to set up their first rocket, actually, one of their team members got corona, and so they had to exchange the full team, and they did that. So they just deployed 5 new people to set up the rocket.
Yeah, I mean, the flexibility that you have when only having 5 people set up and launch a rocket. I think, all of these, they're working on different aspects of facilitating the space industry. So it's really exciting. And then there's ISAR Aerospace. They had their Series B funding in December. They're based out of Munich, which is not too far from here. They raised $90 million and were backed entirely by German companies, but they're only planning commercial launches in 2022.
So they are planning to reduce the whole planning time and cost of developing a rocket as well. They want to bring it down, the payload price, want to bring it down to $1,000 per kilogram, which is close to what SpaceX is already being able to achieve with Falcon. And but for them, payload means microsatellites in the LEO. So they want to deploy microsatellites there for GPS, for agribusiness, as well as media companies and internet firms. They are building both a new rocket as well as a new launch pad. So launch pad is the physical deployment space for the rocket. And they want to make it smaller and less expensive. And they've already have committed pre-sales from different industry players of 500 million, I think, US dollars or euro. An additional example is Aevum. Aevum is interesting because their rocket looks like an aircraft. Essentially, it is like an aircraft. It doesn't need any launch pad or starting missile. It's mostly reusable and it's fully automated. So they are setting up a small payload orbital delivery system. They already have $1 billion in US government contracts. And they want to set up a logistics end-to-end launch service, which means they integrate the payload, they transport it, and they set it up. So this is also really about, let's say, the Moore's law of space logistics. So everything should become cheaper, faster, and more efficient. So this is where we are right now. This is exciting. This is happening.
Exactly. And now the kind of next aspect that we mentioned with rockets was fuel. The two most popularly used fuels are kerosene and biopropane, where biopropane has about 90% less emissions. So SpaceX's Raptor engine, for instance, uses liquid methane and liquid oxygen at very low temperatures. And these are easily available, they're cheap and very energetic fuels. Another experiment that NASA is running, or an idea that they're playing with, is solar thermal propulsion. And this is just capturing solar energy, and they're planning to send a probe to space with it so that you can use solar energy to reach into space.
Yeah, we were also looking at Orbex, which is a UK-based company, and they're integrating a lot of the things that we mentioned so far. So they are using biopropane as a fuel, which has 90% less emissions, as you said. They are targeting to leave no post-launch debris, which is another important aspect. They are trying to reduce waste for their rockets. They are also using 3D printing in rocket fabrication, and they supposedly just need 5 hours to print out an engine, which seems crazy. Wow. They can reduce the weight of the rockets by 30% by using carbon fiber. And they have a specific launch process, which includes 2 stages and 7 engines, where, as the other companies, they have a process for what happens within, let's say, our atmosphere, and then what happens in vacuum. And also they are connected to building the first European spaceport in Sutherland in Scotland, which is supposed to open in 2022 or later.
Exactly. So much to fuel. Then we have the actual thrusters. Recently, MagDrive developed a high thrust and high efficiency propulsion engine for satellites, and their plasma-based solution is supposed to combine the best characteristics of both worlds. So the performance of traditional chemical thrusters and the efficiency of electrical thrusters. So much to thrusters, but this has been a space where we're still looking at what MagDrive will release. And yeah, I think the more interesting aspect is the reusability. Obviously, we have SpaceX with their landing boosters, which made a big difference compared to the way NASA used to launch. When their boosters would fall into the ocean, they had to pick them up, restore them, and then refuel them. Whereas now with SpaceX, they land. All you have to now do is just go through another routine check, repair them, clean them, and refuel, which should not take more than a few days. So this is already a big leap. Rocket Lab is another one. They successfully launched a reusable rocket a month ago on November 20th, thanks to what they call a drogue parachutes. And the payloads were ocean traffic monitoring satellites and communication satellites.
Yeah,
so much
Another important aspect is the astronauts, because a lot of space missions need humans to undertake the important tasks. For instance, to get new. Another important aspect is astronauts, because we tend to forget that a lot of space exploration still has to be done and will have to be done by humans. Now, the life of an astronaut is quite challenging, let's say, because as you can imagine, being in a spaceship for a long time is essentially an environment of monotony and loneliness and isolation, which can easily lead to mental disorders and depression. Another one is the lack of gravity, which causes osteoporosis, which means that your bones are losing minerals, which means they have a decreased mass and increased fragility. Per month in space, you are supposed to lose, on average, 1% in bone mass. What has to be done against that is the astronauts have to take vitamin D and calcium, and they also need to work out a lot. So heavy lifting going on in space. Another one is lack of sleep and sleep disorders. Being an astronaut is also quite a stressful job. And it's quite difficult, even if you have a weekend, to sort of uphold some normal habits. And essentially, it's hard to sleep and catch a good night of sleep.
Yeah, I think an issue in lack of sleep is also just the fact that, for instance, on the ISS, you have they circle around the planet in 90 minutes, which means that you have a sunrise every 45 minutes, sunrise and sunset. So the role of melatonin and just having a natural or the natural clock within us that kind of dictates when we're tired and when we're awake really gets confused. And yeah, that's a big issue, these sleep disorders.
So all these circumstances, they lead to exhaustion, fatigue, headache. The life of an astronaut is quite hard. And this is also significant because when we, as non-astronauts and big masses, when we should be traveling to space in the future, then we'll also face these challenges, and we need to find a way to make space travel more convenient. Now, the human side of all of this also becomes apparent if we look at international collaboration. Because while international collaboration has been something very important for space exploration, for the space industry in general, and while we've seen a lot of big international collaborations, it's also quite challenging, and national boundaries and sort of the ego play between nations continues to be an issue in space. Now, if you look at ISS, so the International Space Station, that's really a project that has been set up over a decade by the different space nations. China has been not part of that. China is setting up their own space station, or is planning to do that. The US recently has withdrawn from ratifying the Moon Agreement, which talks about how we should explore and industrialize Moon and what we should do with it. And an executive order by Trump in last April has also declared that US is not viewing the space as global commons. So US is pushing back on the idea of space is something that we all collectively share and have an equal share of saying and opinion in it, which makes sense if you look at also the contributions, because it's an old problem from microeconomics. Who is contributing what? Should I be contributing or not? Because I'm not reaping the benefits all by myself.
Exactly. Yeah, I think that cost benefits analysis is important. But on the other side, if you look at the space infrastructure that exists or that we are planning to build, I mean, like the International Space Station that you mentioned, it was a collaboration between, I think, almost 30 nations. It was assembled over a decade, and it's the size of about a football field, and it serves as a research facility in space, and how materials behave in space and zero gravity. As we mentioned before, it orbits the Earth every 90 minutes, and most manned space missions take astronauts from Earth to ISS for usually up to 6 months. Fun fact, I think Domino's Pizza or Pizza Hut once made a pizza delivery to space on one of the missions, making that the longest pizza delivery in human history.
Another important aspect of sort of space infrastructure is we need to refuel our rockets, and we need to have fuel and energy in general in space. Now, space is a place where there is abundant energy, which we will also explore later on in habitation. But one interesting startup or one interesting project here as well is Orbit Fab, again, like ESAR Aerospace from Munich, which has just received the Series A round, with the lead investor being Munich Re. They are planning to build gas stations in space for rocket refueling. So consider this, now there is a whole industry just about building gas stations in space.
Yeah, and further, I think this is one of the more sustainable or promising ones is the European Space Agency, or ESA. They're looking to fund a space-based solar station to provide Earth with energy. So yeah, the challenge here is to launch these large scale and very light but still robust solar panels. And the potential or the potential solution here is a satellite swarm, which each provides a part, or you use 3D printing. But yeah, and then there's the, how do you convert this energy and send it down to Earth? But Japan and China have shown that this works. So China is working on a system called Omega, which they aim to have operational by 2050, meaning that if we could have these solar panels work on a large scale and transfer enough energy, we could have enough energy to the point where we don't need to depend on fossil fuels, dams, wind energy, or any of these.
No. The reason that space travel has become cool, so to speak, one of the big reasons is Elon Musk's involvement. So what he has done is, based on SpaceX ambitions and based on the idea of building something high-tech quickly and finding a business model to then further improve it. All of this has really fueled the whole industry, and a lot of players are now challenging each other, building new innovations, but also working collaboratively with each other. As mentioned before, Musk has really bold statements, really bold plans, just like with any matter that he takes on. And for space, he wants to send people to space by 2024 to 2026. And he wants to have the first unmanned Mars flight by 2022 to 2023. Now, currently, and the reason that SpaceX is making money is the Falcon rockets. And the Falcon rockets is, or the Falcon 9 more specifically, is the most advanced rocket in operation to date. It carries out operations for NASA and ISS. It can lift up payloads of up to 22,800 kilograms into the so-called low Earth orbit, or LEO. And it actually, and LEO is actually the place that hosts most artificial objects or most human-made objects in space. Falcon Heavy is one specific type of Falcon rocket that can lift really heavy payloads. The price that Falcon Heavy achieves is currently at $1,400 per kilogram. Now, but recently they've come up with a new generation of rockets, right?
Yeah, so the so-called Starship, which is based on the BFR, the Big Bleep rockets, known as the SN8, and very recently it's reached a height of 12 kilometers, but it failed to land. And yeah, it's a step into bigger rockets, into rockets that serve purposes beyond just transporting satellites or even humans to the space station, but to go much further. And they tested the withstanding of the Starship with the Raptor engine, which is a liquid propellant rocket, so the liquid oxygen and liquid methane combination. And they're already testing SN9 and SN10. These will follow. And as we mentioned, SpaceX really has been a game changer in that they've made a new space race, a new era of making space travel exciting, promising, and just they've inspired many more companies. Another big player.
We don't want to go too technical, but one of the reasons that Starship is an advancement from Falcon is Raptor, which is the new engine, as you mentioned, which is the predecessor of Merlin. Merlin was the engine that was placed in Falcon. And as you've already mentioned, it uses different fuels, but it also has a different process of burning or getting the energy to move forward. So the exhausted gas that is produced would normally and historically be dumped overboard after spinning the turbine, but instead now it is routed back into the combustion engine and thus used for additional thrust. So which means that Raptor is both more fuel efficient but also high power.
And now we come to NASA. I think the most known space agency in the world. Their plans for space exploration and colonization is first sending humans to the moon in Project Artemis by 2024, and then creating a sustained presence by 2028, which is a big deal because we'd be setting foot on moon for the first time in 50 years. They're also working on a space launch system, the SLS, and they hope to transport more than 50 tons of payloads into low Earth orbit using a heavy lift launch vehicle or rocket. And this is a collaboration between NASA, Lockheed Martin, Airbus, and Boeing. They're also planning a lunar outposts, by 2028, a permanent presence of humans on the moon. We all know the Hubble telescope, one of the largest and most versatile telescopes in space, has delivered beautiful images that allow us to study and understand the universe, its history, its processes, and also to map the observable universe, even though that seems very hard. Now they're also working to get close to the sun with their so-called Parker Solar Probe. It was launched in 2018, and by 2025 it will travel at 0.064% of speed of light, based on the sun's gravity alone. And this is called a Oberth maneuver, and it utilizes the gravitational force. And the development of the heat shield actually took very long, which is the reason why they only launched it 2 years ago. But it'll be interesting to study the sun, its corona, and understanding the sun better.
Yeah. Another part that you already mentioned is the HLS, the Human Landing System, which is part of the whole Lunar Outpost project. So Lunar Outpost will be very significant, considering also that other technologies and lots of suppliers play into this. The idea of having a landing system for rockets that have humans, and the idea to become a hub for science, engineering, research is also fueled by other industry players, like in this case, Blue Origin, SpaceX, and Dynetics. Talking about Blue Origin, which is Jeff Bezos's company in space, what they are doing is they are manufacturing spacecraft and provide suborbital spaceflight logistics services. So think of their business model as being very similar to SpaceX. So in this case, you could actually refer to them as being also competitors. Now, their R&D is focused on reusable launch vehicles as well. And they are also experimenting with what we call vertical takeoff and vertical landing, which essentially means exactly what it says, right? So rockets do not take off the same way that aircraft does for many reasons, which some of we already explained. And they are also building a lunar lander, which is actually part of the NASA Artemis program, which is the Blue Moon, part of the 2024 goals of NASA. And as well, they are building onto the human landing system of NASA.
Exactly. Then we have China's National Space Agency, or CNSA. They are not part of the ISS, but they want to launch their own space station in the coming years. But they have made many big steps. For instance, they just brought lunar material back to Earth for the first time in 44 years. From the far side of the moon, they were also the first nation to land on the far side of the moon and even exploring it with a rover. And their Tianwen-1 is on its way to Mars, and it's planning to land in 2 months by February. But out of 18 Mars landings so far, only 10 have been successful. So we're, of course, wishing all the best to Tianwen. And we also have the European Space Agency, another one of the big players. They've participated in the ISS in human space flights. They've also launched uncrewed exploration missions to the moon and even other planets. And they're also designing launch vehicles. They're working on Earth observation, science, research, and communication. And they're also maintaining a major spaceport.
Yes, so the Guyana Space Center in Kourou on French Guyana. They've also been part of funding different projects like the space-based solar energy station that we've talked about before, which could provide energy to Earth as well. Some of the other space agencies that are sort of pioneering and leading the field are UK and Japan. And another big player as well is Lockheed Martin and Boeing, being one of the main contractors of US defense when it comes to space budget and space projects. Now, we've looked into the whole space travel and space logistics part of it. We've looked into the different players, the advancements, and what sort of needs to come together so that we can bring payloads and humans into space. But what we also need is we need to think about habitation and space exploitation.
Exactly. So space colonization, Exactly. So space colonization means not just creating a habitat, not just survival, but also the exploitation of the many resources that you can find in space. And there are some arguments against space colonization, maybe that they could enhance existing power structures, create a wider equality gap. There are people who are against exploitation or the fact that a nuclear war would be more acceptable because we have a backup on other planets. And maybe also people are just worried of the fact that huge investments will be put into space and the outcome isn't really certain. And many people complain that why are you fixated on going to Mars? We have many more urgent problems right here. And while these are fair arguments, there are also arguments such as hostile conditions and other threats that generally need to be overcome to ensure a safe travel in space. You have extreme pressure differences, very high pressure, very low pressure. You have the extreme heat. So some planets are very hot. On the other hand, outer space is close to 0 Kelvin. And you have all sorts of other aspects like gases and radiation. But the one planet that has been chosen is Mars. And I think the fixation on Mars is a very simple process of elimination. The planets beyond Mars are all gas planets or even gas giants because they are so huge. We don't know what their actual surface is like, whether they have, how large the gas amounts are, and the conditions there are quite brutal. On the other hand, or on the other side, you have Venus and Mercury. Venus is considered the twin sister of planet Earth, but Venus is also the hottest planet on Earth. And compared to Mercury, Mars just has presence of water in form of ice, and the conditions are very similar to Earth. So there is an atmosphere. It is very thin, but it does have an atmosphere. Water is scarce, and the lack of gravity are a challenge. But Mars is the nearest and best candidate that we have within our solar system for colonization.
The whole history and idea of Mars exploration and space exploration really counters the idea that we have about human innovation and sort of human innovation cycles. Because 50 years after we've been to the moon, we still are not quite further with this. And you could see actually, you could look at the national budgets for space. And after they've reached a peak in the 70s, they've really decreased and declined to much smaller amounts and even smaller amounts today. Now, this is in part explained by what we've said before. This is very expensive, and I think this is also a main difference towards other technologies. Exploring space is very expensive and time-consuming. And as societies, we sort of faced other challenges. And it also is related to geopolitics and the idea why US and Russia have explored space in the first place. But as we now come towards exploring this whole idea of inhabiting another planet, specifically Mars, again, a big part of it is we need to think about how can we make Mars habitable? And the most habitable part of Mars is still much worse than the least habitable point on Earth. So the main idea that is being pursued is sort of a logical one, which is we create a closed space on Mars which resembles what it's like on Earth. And we call this so-called CELSS, or a controlled ecological life support system. And we also call this terraforming a planet. And this has been tested for quite some years now. The most prominent example is Biosphere 2, where Biosphere 2 is sort of a closed ecosystem on Earth that feeds itself and has no sort of outside influence. And the test that they've undertaken in Biosphere 2 is they sort of closed 8 people into Biosphere 2 for 1 year. And they survived, but after 1 year, they actually had to replenish the oxygen. So you could say either it's the whole test passed because they could survive there for a year, or you could say they failed because the initial expectation they had was that the whole system would last and feed itself for 2 years. Now, what does it mean to have a closed ecological life support system? Maybe we can explain that further.
So, yeah, as you mentioned, there's the aspect of self-reliance. So eternal recycling, but there's also, this goes much beyond just oxygen or water. We also constantly need food. So this means that we need some way of converting carbon dioxide that we breathe out to oxygen, to breathable air. We have trees for that. That would be one solution. Then there need to be systems in place that can replenish our demands for food and water. And then the bigger question that arises from these are, whether we can live in a CELSS or in such a life support system, is whether it's actually healthy for us in the long run. I mean, a project or a experiment of 8 people living in one life support system for 1 year is different than having to sustain a colony of hundreds or maybe even thousands of people on a foreign planet, right?
Without being able to replenish the oxygen just like that. Yeah.
That does sound scary, yeah. So there are some technical challenges that we need to overcome to make sure that we can live in a completely self-sustaining environment, that we can create such a thing on a hostile environment. One approach I read was to modify human genetics to kind of create a subspecies of Homo sapiens, which are more adapted to living on the moon or on Mars. And yeah, to be honest, that does not sound that appealing. As of now, we don't know what the health consequences are. But I think, as in many advances in science, if we just model our approach close to what nature has already provided, I think we can do a good job. So if we find a way where we can maybe interact with plants and maybe 2-3 other species such as algae, etc., to replenish or refurbish our demand, and just create a cycle where our waste is used and then transformed into materials that we can reuse again.
And this also applies to space travel, right? We can think about what astronauts have to go through. We've mentioned that before. But when we all want to colonize space, we obviously also need to travel to these other planets. And then we have a lot of challenges for making this human, making the whole travel experience human. But onto something that is where space has advantages, because space also has advantages. We mentioned some of them. Space has an infinite and incomprehensible amount of energy, but also materials and sort of conditions that simplify manufacturing processes. And one of them is the lack of gravity, or the existence of microgravity, which applies to, or which means less sedimentation, and it simplifies mixing some materials. Another one is vacuum. Think about the fact that a lot of industrial companies are seeking to create a vacuum to produce pure and high quality materials. We naturally have such conditions in space. Then think about extreme temperatures that are given by sunlight, and also think about radiation. This helps us in heating stuff, but also freezing stuff and making it conservable. We can also produce strong and glassy materials based on this. So these conditions really have big advantages for us to do, for instance, 3D printing processes in space.
We just have to find out how to exploit them efficiently. These benefits that you mentioned, yeah. And I mean, when we're talking about space exploration, or even as we're going to get in now with asteroid mining, there's no real limits, right? I mean, we know that just in the asteroid belt between Mars and Jupiter, there are tons and tons, thousands of tons of all kinds of metals, gold, platinum, silver. And this is just one solar system in one galaxy. I mean, there's an incomprehensible amount of energy and materials that are waiting to be mined for our use and purpose. And we mentioned the asteroid mining. Many say that the first person to run a asteroid mining company will be the first trillionaire. The fancy word for extracting and processing these raw materials is known as in situ resource collection, ISRU. This basically means that you mine, you extract and process the materials in space and transfer them to Earth. There are some challenges involved. Others have suggested maybe transporting the raw asteroid to closer to Earth, where you have a bigger station that processes the materials and then sends them in shipments to back to the surface. These are all things that will kind of will just happen, and we'll see which is the most cost-effective method. And as we know with Moore's law, the more advanced we get, maybe we can build extraction and processing stations further out. There are a horde of extraction techniques to date already. You have merely just surface mining or shaft mining, where you kind of dig a shaft into the asteroid, or you could use magnets, you could use heat. And there's another process called the Mond process. I'm not so familiar with that one. Would you mind?
Yeah, so that's very, very complex, and it's beyond our scope here. But we're talking about nickel and iron-rich planets, and using a process that is composed of using carbon monoxide, pressure, and heat to produce at the end of it rare materials like platinum and gold. Interestingly, so there's two potential scenarios when this whole idea of asteroid mining becomes economically viable. There's an exciting one and there's a really scary one. Which one would you like to have first?
The scary one.
So the scary one is when the demand for essential materials on Earth is that high in the price that mining them on other planets and asteroids becomes economically viable. So think about if we run out of water or run out of basic materials that we need for life on Earth, then mining on asteroids becomes viable. So that's a very scary projection, and I hope it will never be the case. The second one is much more exciting, which is when the cost of extraction and the cost of technology and technological innovations are becoming prevalent, and the cost is reduced as much so that it becomes economically viable for also non-trillionaires to undertake this mission.
Yeah, but the amount of metals that we can reap just from our solar system is crazy. I mean, just think of what happens to the markets when gold floods everything. We'll all be walking around with gold headphones and gold computers and gold everything. But it's a very exciting prospect for sure. I definitely hope that we attain asteroid mining through the more optimistic way, through increased technology and not increased demand. And now, yeah, to wrap up all of this into one exciting day, we come to our utopian section. So, in a world where you have space exploration and space colonization is a reality, where humans have now become a interplanetary or even maybe interstellar species, tourism now takes on a new meaning. So you could maybe wake up on Mars in a life supporting system, and maybe you have a day off. You decide to visit your grandparents back on Earth. You visit them, and they will tell you about how in their day they used to take flights and not rockets. And maybe for lunch you quickly take a hop by the space station, or maybe even venture out to the moon to see if any new restaurants are opened. And what do you think will happen on the more science side of things?
In order for us to get to space, in order for us to understand space, we most probably will have to update our understanding of relativity and quantum mechanics. This means potentially, and this is just a theory, but this means potentially that we have a better understanding of consciousness, we have a better understanding of our brain, and we have a better understanding of the processes that run us, and we could collaboratively progress our state and essentially become a more intelligent race. Now, if we understand this, this might also be the key, and again, this is just a hypothesis, it might be the key to understanding spirituality, consciousness, and religion. We could ultimately become more happier and fulfilled people. We could do what we love instead of doing what we have to do, but this is also dependent on other technological advancements. It could be that finding your dream partner just becomes a logical process, because you can determine the connections between your minds simply by searching for them, because you can make them visible, or you can make them, you could work with them. So the whole idea of relativity and quantum mechanics, the whole idea of understanding space, of exploring space, could bring along scientific advancements that also have huge impact on life on Earth.
And other planets, right?
As well.
And yeah, I think another aspect is, if we have to now open up a rocket refueling station in the lower orbits, or in space between the Earth and Moon, or maybe to start up new industries on the Moon, this will create a huge influx of new jobs. And remember that we have a lot more physical materials, so extracting things, working in mines will no longer be necessary, meaning that we have a reduced poverty and inequality, since we don't have resource scarcity, but we have increased opportunities for people to work not just anywhere in the world, but anywhere in the solar system. So there are very exciting prospects. And I think mastering space colonization, or at least creating what NASA and SpaceX promise, creating permanent sustenance on another heavenly body, such as the Moon or Mars, really might be the biggest thing that happened to humans since the discovery of fire. That is immensely powerful.
Yeah. I hope that what you say will become true in terms of the resources. So yeah, the abundance of resources that could really also change our financial system. So think about, you could invest in something like a Meteor Gold ETF or something like this, where just like today, where you have funds pooled into, let's say, ESG projects, you will in the future have funds pooled into interstellar projects or interplanetary projects. So the whole idea of resource scarcity, when that is changing, that could also change our relation to them and how we abstract it into financial products.
Absolutely. And I think, if I'm being honest here, I think this is one of the most exciting topics that we have hosted on this podcast, just because of the immense impact that we can expect from this. Yeah, as we mentioned, probably the biggest thing to happen, not just to our race, but in our knowledge to any race, since we discovered fire. So this could really be a leap forwards of humanity and hopefully all the other species as well. I hope we're not leaving them behind, to a new era full of exciting opportunities and discoveries.
Yeah, if you plug this into, if you would have a matrix of human innovations and you would plug cost versus impact, then this is obviously a high cost but high impact initiative. And those tend to have long time frames. So we need to be patient when it comes to traveling to space. So you won't be able to visit your relatives on Mars tomorrow. Maybe you will, probably you won't, but we will have to give it probably several decades. But it could be still in our lifetimes that this will be the new normality.
For sure, yeah. I think, yeah, I mean, the plans of NASA and SpaceX are ambitious, but I think by 2050, the world will look a lot different. Maybe the moon will look different too, who knows? Yeah, and I think for next week, we have quantum computing planned, so that's another really exciting topic. Maybe the impact isn't as big as space colonization, but I think it will be there in the top 5 of our UTX ranking, impact wise. And as usual, stay safe, enjoy your holidays, stay utopian.
You're maniacs.